Just joining us, this is part of an ongoing series following the complete build and sailing of Alice Gale, a wooden Ebihan 15 sailboat. All episodes are linked in the description. I started with 8 boards per side, each one shaped, fitted, and fastened. 8 planks on the starboard side, 8 on the port. But that last plank, the Sheer Strake, that's different. That's not just another board. That's the moment planking is done. Before any of these planks went on the hull, each one started as 2 sheets of plywood scarfed together at a 12:1 ratio. A long tapered joint glued with thickened epoxy, clamped with weights and small wedges. I used 16 sheets of marine plywood to make the 16 hull planks. A 3-inch by 48-inch scarf joint to create each 4-foot by 16-foot plywood sheet. The full-size Mylar plans provided the correct shape and size for each plank. 8 finished boards per side. Some of you more knowledgeable viewers will know that the proper name for the hull planks used to construct a lap strake hulled boat have special names for each board. They are in the language of boat building known as strakes. While I have been using a general term for the hull planks, calling them planks or boards somewhat consistently throughout this and previous videos, the correct nautical term for a hull plank is actually a hull strake. And, depending on location, it can be called any of the following. A garboard strake, the lowest plank, running right along the keel. It's the first one fitted and arguably the most critical. Then the broad strake, the plank directly above the garboard, named for being typically the widest plank on the hull. And the bilge strake sits around the turn of the bilge, where the hull transitions from bottom to sides. Adding more types of strakes, you have the topside strakes, the general term for the middle strakes running up the sides. On a simple hull, these may just be numbered 1st, 2nd, 3rd, etc. above the bilge strake. And finally the sheer strake, the uppermost plank running along the sheer, the top edge of the hull. It's the most visible plank and often given extra attention to fairing and finish. I will be using the new, more accurate terms for strakes in my future commentary. In my last video, I had a contributor who indicated a scarf ratio of 8:1 is more of a standard ratio for plywood scarves. My 12:1 ratio may have been a bit overkill for structural strength, but is an alternative recommendation for areas with high bending stress, so I went with the 12:1 ratio. Planing, chamfering, fairing, it's repetitive work, the same steps, over and over, but it's necessary. Each strake needed finishing before the next one goes in. The process was always the same. First, after the strake was fastened and epoxied, I'd remove all the temporary screws and clamps. Then came planing, using a hand plane to fine-tune the strake's curve to match the shape of the hull. It sounds simple, but it's not. Each strake had to fare smoothly into the bulkheads and the strake above and below it. If there was a humped area or a hollow spot, the plane would show it immediately. None of this would have been possible without clamps. I had made up about a dozen homemade board clamps before attaching the 3rd strake. Each strake needed enough of these board clamps to hold the strake in position, using them along the strake's length to hold it tight against the bulkheads while the epoxy set. Mechanical clamps at the stem, backing blocks as anchor points, temporary screws where nothing else would hold. After planing, I'd round the edges slightly, a small chamfer along the top and bottom. That softened the strake's edges and made it look finished, less raw. Then came the fairing coat. I'd apply epoxy to the entire strake surface and let it cure. This sealed the wood and filled small gaps or imperfections. One thing I learned the hard way, don't prime the hull until every strake is on. As a novice, I got ahead of myself. I sanded and primed early sections because they made for good photographs. And then every time I installed the next strake, an epoxy drip would foul the primer underneath. I spent more hours on touch-ups than I should have. The same goes for spills. Wipe them while the epoxy is still soft. Once a drip hardens, you're sanding or chiseling, and that's time you don't get back. Once the epoxy cured, I'd fill any screw holes with epoxy. Then came the tedious part, sanding. Every surface had to be smooth and fair before the next strake could go on. I couldn't leave bumps or rough areas because they'd telegraph through to the next strake. I also had to cut the ends of each strake to length. The strake were left long during installation to ensure a proper fit. Once they were fastened and the epoxy was cured, I'd use a pull saw to cut them flush to the stem and transom. That created a clean, finished edge. Another critical step was chamfering each strake. The chamfer is a beveled edge cut full length on the strake's face to match the angle of the hull curve. Each bulkhead, those frames inside the boat, had been set at a slight angle. The strake had to match that angle exactly, or they wouldn't sit fair. The chamfer ensures that when the strake is fastened, it sits snug against the bulkhead without rocking or shifting. As I moved into May, boards 6 and 7 went in, and with them came a significant decision that deviated from the original plans. The transom, the flat panel at the stern that holds the motor, required a motor well. This isn't a hole, it's a carefully cut opening that sits forward of the rudder and makes it possible to mount an outboard motor cleanly into the hull. The plans showed where this opening should be cut, and I made the motor well to spec. But while doing that work, I realized I'd misread the plans on another detail: the keel's aft edge. The plans called for narrowing the keel's full width back at the propeller shaft area. I only did a narrow indentation around the shaft itself. It was a mistake I didn't discover until much later, and by then the hull was already painted. That's one of those lessons you learn the hard way in boat building. You don't always catch every detail in the plans until you're already committed. The other significant deviation from the plans involved the bow stem. The original design called for a laminated stem, thin pieces of oak glued and clamped together to create a curved structural piece at the bow. I made the choice to use a scarfed solid oak stem instead. A scarfed joint is stronger than a simple butt joint. The plans also called for a rope loop at the bow, a traditional detail that serves as a handle for towing and a tying point. I chose to install a stainless steel U-bolt instead, fastened directly through the backbone of the boat. It's not a classic look, but it's much stronger. A rope loop would eventually fray or break. A stainless steel U-bolt is permanent. These small decisions, solid stem versus laminated, stainless steel versus rope, they're the moments when you move from simply following plans to making an actual boat. Every builder does this. You learn as you go, you see where you can improve, and you make adjustments. Some work out perfectly, some you learn from. With 7 strakes installed on each side, the frame was no longer a skeleton, it was becoming solid. And the moment you install a strake, the work doesn't end. The sheer strake is the uppermost plank on the hull. Sailors call the upper edge of a hull its sheer, the long rising curve you see when you look at a boat from the side. The sheer strake is the plank that follows that line. It's the last board on, and it's the one that defines the boat's profile. From that moment forward, the hull was closed. Not yet painted, not yet sealed against water, but closed. No more exposed frames. No more visible skeleton. The shell was finally a shell. It's hard to overstate what this moment meant. The sheer strake went on the boat. I have been working on the interior, the framing, and now the planking for nearly 4 months. I installed each plank with care, but until that sheer strake went on, the boat was still just a frame, still just potential. The sheer strake was the moment potential became real. Because when I installed that last plank, the sheer strake, the hull was finally closed. The structure was complete. After the sheer strake was fastened, the next phase could begin. I had to fair the entire hull, make sure every surface was smooth and uniform. I had to attach the bow stem. I had to fair and finish the hull inside and out. With planking complete, the hull was ready for the next critical phase, the paint, and eventually the second flip of the boat. 8 planks on each side, and not counting the garboard strake. That's more than 250 feet of seams between the wood. Each one had to be perfect, but now the hull was closed and ready. Next comes final fairing, the primer, the paint, and turning a finished hull right side up by hand, alone in the garage.